Okay, so looking at this one, critical values of a one mean z-test and rejection regions. So let's see what we're doing here. Looking at it just without even reading it, I see critical values. I see a table with z-scores. And if you're not sure how to read this, because some of Newton's questions asks you to find a critical value with a given table, that's prior to learning how to do it on the graphing calculator. But this one gives you the table, so you don't have to use your graphing calculator for this one particularly. If they didn't give you the table, then you would. And you have to understand the notation. So this is a z-score and this is the subscript. So this means a z-score with this particular area in the right tail. This is the z-score with this particular area in the right tail. That's what these values are. So in other words, they're doing the inverse norm for you for different scenarios. You just have to pick the one that matches your scenario. So let's read it and see which one matches. I'm going to use blue. So a CEO of a well-known hospital system would like to determine if the anesthesiologists working within the hospital system have a different salary than the national average of 200,000. They conduct a hypothesis test with a significance level of 2%. So determine the critical value for the table for two-tailed tests. We kind of give that away. Draw the rejection region. So you know that the rejection region is the region in which we reject the no. And the rejection region is basically the area of alpha, which alpha is given to us because alpha is the significance level, 2% or 0.02. They tell us that it's two-tailed, but if we didn't know that, I would look for the claim. And I always like to write my claim, my null and my alternative. I always like to do that. And I look for the claim. He wants to determine something. He wants to determine if the anesthesiologists working within the hospital system have a different salary than the national average. So, is the salary the same or is it different? So is it equal to or is it not equal to the 200,000? I'm not going to write it. Well, I didn't have space for it. But anyway, the idea behind writing that is when you have the alternative hypothesis, which is a not equal to, it tells you that you have a two-tailed test. So based on the fact that it's a not equal to, we know it's a two-tailed test, even if they didn't say it here, which means that we have to take our significance level and split it into two pieces. So I have to cut alpha into two pieces, which gives me 0.01. So 0.01 area in each tail. Now, I'm going to draw it, but I want to know the critical value first, just so my figure is nice and, clean and accurate. Being that 0.01 is the area in the tail, which is the rejection region, I'm looking at this z-score. And when we have a claim and it's two-tailed, we have two rejection regions, and thus we have two critical values. But if you remember, or hopefully you know, that you have a symmetric bell-shaped curve. So the critical value on either side, they're the same. It's just one is positive and one is negative. So 2.326 is like ish here, 2.326. And I have an area to the right of that of 0.01. This is my rejection region. And it's a two-tailed test. So I'm going to go on the other side, which is going to be here, this negative 2.326. And I have the area to the left of that is 0.01. And this is also my rejection region. I have two rejection regions for a two-tailed test. And thus alpha has to be split into two pieces. And if I were to use the graphing calculator, I have to do inverse norm. I don't have to do that here because the table was given to me. And I know the z-score corresponding to this little area in the right tail, which matches my situation here. So my critical values, which are two of them because it's a two-tailed test, are positive and negative. I'll write it here, 2.326. Okay.